Hello students, this is the second lecture of geometry. In the first lecture I taught you the similar triangle properties and the theorems related to it. Now today I am going to explain some more things related to the triangles and the questions related to it. So guys, suppose two triangles are similar. If two triangles are similar, suppose one triangle is ABC and another triangle is PQR. So if triangle ABC is similar to triangle PQR, then please do remember then that the sides are proportional. The sides are proportional. As I already told you this thing. The second one is angles are equal. Angles are not proportional. Angles are always equal. And the next thing is perimeter is proportional. Perimeter is proportional. Then altitude is proportional. Altitudes are proportional. Then the next one is median is proportional. Median is proportional. Area is not proportional. Please do remember, area is not proportional. Ratio of area is equal to square of ratio of sides. Ratio of sides. This happens here. So please do remember these important properties. One more theorem which is very important, sometimes we can use it, that is Apollonius theorem. Apollonius Apollonius theorem. Is that clear? So the theorem says that this is a triangle. This is A, this point is B, this point is C, and suppose this one is median, that is AD. So AB square plus AC square equal to twice of AD square plus DC square. This is Apollonius theorem. Is that clear? So now we take some problems related to the theory of similar triangles again. Yes please. Suppose this is a triangle, right angle triangle, and this angle is 90 degree in this triangle. Now there is a square. This is the square. Suppose this point is A, this point is B, this point is C, and this is suppose P, this is Q, and this is R. Is that clear? So suppose the sides of the triangle are, this side is 4, then this side is 5, then find the area of square. The question is this: what is area of square? Is that clear? Now how to solve this problem with the help of similar triangle concepts. Now see this thing, this angle is 90 degree, as it is a square, I already told you. So this would be again 90 degree. Is that clear? Now suppose the side of the square is x, then if the whole height is 5, then this one is x, then the remaining is 5 minus x. Is that clear? Similarly, again this is x, and this is x. So this complete is 4, so this would be 4 minus x. Is that clear? Now I am going to compare these two triangles APQ and this triangle QRC. Will you believe these two are similar? I can explain you. As this angle is 90 degree, here this angle is 90 degree, means my angle P is equivalent to angle R. So that's why P is equivalent to R. One more thing, these two lines are parallel, as it is a square, so these two lines are parallel, so this angle will be equal to this angle. I can extend so you will be able to visualize it properly. So this angle is theta, then this angle is again theta. So that's why angle Q is equal to angle C. So Q is equal to C. If two angles are equal, then it's enough. Third angle has to be equal, definitely. So these two are similar triangles, and if the triangles are similar, then the sides are proportional. So can I say AP divided by PQ? This I am taking. Proportionality means if I am taking here AP upon PQ, means I am taking first, second, and second, third, then here also we should take in the same way. So QR divided by RC. So what is AP here? 5 minus x divided by, what is PQ here? X equal to QR, that is X divided by RC, that is 4 minus X. If we cross multiply, then what do we get? X square equal to 5 minus X multiplied by 4 minus X. So X square equal to, if I multiply, then 20 minus 5X minus 4X minus minus plus X square. Is that clear? So this X square cancels with this X square. So 5X plus 4X, 9X. So it comes here 9X equal to 20. So X equal to 20 by 9. Is that clear? So this is very important question. And if you find the same question again in the exam, same question with different data, do one thing. Multiply these two numbers and write in the numerator. 5 4s are 20, and add these two numbers and write in the denominator. So this is very simple trick, you can remember. The same type of question repeats again. Is that clear? No problem. Now move on for the next question. Suppose this is one vertical tower, this is another vertical tower. The height is here 10 meter and the height is here 15 meter. Now this is the path between the two. If I join from this top point to the bottom of this one, and if I join this top point of this pole to the bottom of this one, is that clear? So this is 90 degree, this is 90 degree, and this height is to be determined. That is the question. What is the value of h? This is very important question. Many times it is asked. Recently also it is asked in JEE Mains also, and it is asked in competitive exams like CAT, ZAT, CMAT, etc. So first of all, suppose this is x and this is y, right? So if I compare, I can give the names A, then B, then C, then here D, then here E, and here is F. Is that clear? Now I am going to compare two triangles. Suppose I am going to compare this triangle BFE, this BFE, this is small triangle, and this bigger triangle, that is BCD. Now can we say these two are similar, as the angle B is common in both? See, this angle is common in small triangle as well as bigger triangle. Now this angle is 90 degree and here this angle is 90 degree. If two angles are same, then it's enough. Yes, no? Now the sides are proportional. So can I say the base BF of a small triangle divided by altitude of a small triangle, that is h, this EF. What I am taking? BF, BCD, and this is BF, sorry, it is E, BFE, don't confuse. So what I am taking here, base of a small triangle, that is x, BF, divided by perpendicular of a small triangle, that is FE, so that is h. Here also we should take same thing, BF instead of BF, first second, here first second is BC. So what is that? X plus y divided by the height is 15. Simply we can say this, base of a small upon perpendicular of a small equal to base of large triangle upon perpendicular of large triangle. Simply the sides are proportional. Suppose this is equation number 1. I don't think any problem should be there in that. So what I did, compared these two triangles. Again I am taking this bigger triangle and this one is smaller triangle. This one I am asking for this one. So that small triangle I am taking CFE. This is small one. This should be similar to CBA. So the base of a small triangle y divided by height of a small triangle h equal to base of bigger triangle x plus y upon perpendicular of bigger triangle, that is 10. Directly I can write this equation. So I got two equations, 1 and 2. Now I am adding these two equations, 1 and 2. Adding the equations 1 and 2. So what do I get? X divided by h plus y divided by h equal to x plus y divided by 15 plus x plus y divided by 10. So if I take common here, h is LCM, sorry. Now numerator I will get x plus y. This is h equal to, what is common here? X plus y. So what do I get inside the bracket? 1 upon 15 plus 1 upon 10. So x plus y cancels with this x plus y. So 1 upon h equal to, what is LCM here? 30. So 15 2s are 2, 10 3s are 3. So basically 2 plus 3, 5. 5 by 30. So 1 upon h equal to 5 by 30, that is 1 by 6. Yes, no? So h equal to 6 is my answer. Is that clear? Now again I will show a shortcut. If same type of question you find, again this one is 10, this one is 15, and this point is joined from this point is joined from this, and what is height? Simply what you do, just multiply these two in the numerator, just add these two, that is 25 in the denominator. So this h equal to 15 10 ja 150 divided by 25 25 6 ja 150. So the answer is 6. So it's as simple as you can see here. Yes, no? Now move on for the next question. It's very important question for the same similar triangle property concept. Yes, please. Suppose this part is there is a swimming pool and this is the base. The slope is like this, and this height is supposed to 2.5, and this complete one is 4, suppose, and this is the water. It is filled, not full, it's up to just base is covered like that. Person is standing here such that some part of its body is inside the water and some part is outside the water. Suppose this length is 3. This length is 1. That's it. The only question is find the height of person. Height of this person, right? This is the question. How can we apply the concepts of similar triangle here to get my answer? This is 2.5. So this should be 2.5. You agree with that? This I don't know. Suppose this is h. This complete is 3 and this one is 1. So remaining part is 2. Are you agree with that? Next thing, this complete is 4 and this one is 2.5. So can I say the remaining one is 1.5? Is that clear? Now this angle is 90 degree. This angle is 90 degree. So see these two triangles, this is small triangle and this big triangle. I can give them name. So this is suppose A, this is B, this is C, this one is D, and this one is E. Is that clear? Now I take two triangles, that is A, B, C, A, B, C, and A, D, E, A, D, E. What do you observe? These are similar triangles because A angle is common in both. As this angle is 90 degree, this angle here is 90 degree in the bigger triangle, and two angles are equal, so that is enough. Is that clear? Now again the sides will be proportional. So can I say this length AB divided by BC AB divided by BC equal to AD divided by DE. Do you have the length of AB? No, I don't have. Do you have the length of BC? No, I don't have. So there is no need to apply such concepts, such equations don't make, where we don't get anything. Okay, we do something else. Now, can I say this BC divided by CA? Means in this small triangle I am taking this perpendicular and this hypotenuse. This should be equal to the ratio of the perpendicular and hypotenuse in the bigger triangle. So 1.5 divided by 3. Yes, no. So what is this BC? That is H divided by what is CA? That is 2. H upon 2 equal to 1.5 divided by 3. So 1.5 2s are 3. So cross multiplying 2H equal to 2. So H equal to 1. Is that clear? So the height of person is this is 2.5, the portion outside the water, and this is the portion inside the water. So this is H and H is 1. So 2.5 plus 1. So this is 3.5. Is that clear? So this is my answer. So this is also not a very tough question. Just we need to apply these things here. I hope that this is clear. Okay, now I would like to explain some more concepts in which we can apply the property of similar triangles, right? See, there is very important theorem that is known as alternate segment theorem. Sorry, first of all, tangent secant theorem. First of all, what the theorem is, I would like to explain. Suppose this is a circle and this is tangent. You know what is tangent? Yeah, a line which touch the circle at any point, or which touch any geometrical figure. Not only tangent, always you will find in circle. Suppose this is a diagram which is parabola. So everywhere you can find tangent. This is tangent. This is tangent line. There are more than one tangent also for the same figure. So here also on this circle many tangents can be drawn. Suppose this point is P, this point is A, this point is B, and suppose this point is T. Is that clear? So PA multiplied by PB equal to PT square. This is the theorem that is known as tangent secant theorem. Is that clear? Now I would like to explain how this is possible. Suppose I join from B to T, and I join this also, A to T. Is that clear? Now suppose this angle is theta, then this angle will also be theta. This I will explain just after this theorem, that how this come. This is also theorem that is known as alternate segment theorem. I will write here, I will explain here. Suppose there is this tangent and this is a line which divide this circle into two segments. Whatever angle theta is in this segment, then the same angle that will subtended here theta in the another segment. So the proof I will give just after this. Is that clear? So if this one is theta, then this is again theta. This is by alternate segment theorem. Is that clear? Now see these two triangles, compare these two triangles. This P angle is common in this triangle, small one, and this bigger one triangle, again this P angle is common. Here this angle is theta and here this angle is theta, means two angles are same. So what to do? First we write P T A. This is small triangle PTA. and again I am writing PTB. So definitely these two are similar because P angle is same in both, and here at T theta and here at B is theta. So sorry, PTA I am writing, so I should write PBT. P, then this should be B and this should be T. The corresponding angles must be equal when the triangles are similar, right? So this T and B angles is same. Here T angle is theta and here B angle is theta. Is that clear? Now PT first second divided by TA. PT upon PA, PT upon PA means first second and first third, that I am taking, equal to PB divided by, here I am taking PA means first third, so here I should take PT, and if I cross multiply, what do I get? PA multiplied by PB equal to what? PT square. Is that clear? So this is the proof of tangent secant theorem. Please remember, this is very important theorem, and it is applied many times in solving geometry problems, right guys? Okay, now as I told you, I will explain alternate segment theorem. Before I explain this theorem, one small thing I would like to share with you, that suppose this is circle and this is tangent line and this is a point, this one is radius, so this would be always perpendicular. This is again a theorem, tangent is perpendicular to radius. One thing. The second thing is, suppose if any arc on the circle is subtending this angle, suppose theta here at the center, then the same arc will subtend at the boundary half of this angle. That is, if this one is theta, then this is theta by 2. Is that clear? So these two concepts are used in this alternate segment theorem. This is again very important theorem. So first of all, I am making this circle, and suppose this is tangent, this is a chord which is dividing this circle into two segments. This is first segment and that complete one is second segment. So suppose I am joining from here this way, and what I need to prove, if this angle is theta, then that angle, this one, must be theta. This is to prove. This only is the alternate segment theorem. So you can say, and from this side either, or from this side, if this one is theta, then that should be theta. Same thing. Now tell me one thing, suppose this one is center of my circle, and if I join from here, and if I join from this point, so this one is my center and this one is radius, so these two radius are equal, yes, no? Now as I told you that this radius is perpendicular to tangent, so this angle is 90 degree. You would be agree with that? And if this angle is 90 degree and this small angle is theta, then the remaining part, this one is what? 90 minus theta. Yes, no? And if this angle is 90 minus theta, then again this would be 90 minus theta, because if two sides are equal, then the angles opposite to them are equal. As it is a radius isosceles triangle, two radius are equal, so these two are equal. Now can you tell me this remaining angle is what? As the first angle is 90 minus theta and the next one is also 90 minus theta, so these two are 90 minus theta, and this I don't know, suppose this one is y. The total of these three angles must be 180, so 90 plus 90, 180 cancels with 180. So what I get? Y equal to 2 theta. It means it must be 2 theta, this one. Is that clear? Now see this arc. See this arc. If this arc is making angle 2 theta at the center, then the same arc will make how much angle here? Half of this theta, as I explained here. Then this is proved that if this angle is theta, then this angle would also be theta. So this is alternate segment theorem, it is applied in many questions. Is that clear? Now one more thing I would like to explain here. I am giving the proof of this thing. As I told you that if this one is theta, then this should be theta by 2. How? See this. Suppose this is center. And I am joining this way. And I am joining this also. Continuing. Now suppose this angle is alpha. This is radius. These two are same. This is also radius. Can I say this is again alpha? And if this one is beta, then can I say this is again beta? So this exterior angle is alpha plus alpha, then it is 2 alpha by exterior angle property, and this is also exterior angle of these two. So beta plus beta, that is 2 beta. So finally this complete angle is twice of alpha plus beta. And what is this one? Complete alpha plus beta. So it is proved that this angle subtended at the center is double of that one at the boundary anywhere. Is that clear? So please do remember, guys. So this is suppose center. So all these angles would be equal. This one, then this one, then this one at the same arc, then this one. But at the center, whatever angle we make, that will be double of just all these. Is that clear? So all these are same, theta, 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 theta. At the center it would be 2 theta. So please do remember these things. Okay, move on. Next question, guys. Again, very important question asked in CAT exam. Suppose this is a triangle. This is perpendicular. This is 90 degree. This one is 90 degree. This one is 15. This one is 20. And there is one in circle in this triangle. This is one in circle. And there is one more in circle here, this triangle, this one. Is that clear? Now the question is this: if the center of this circle is A, and if the center of this circle is B, then what is the length AB? I am asking the length AB. Nothing else is given to us. That's it. Now tell me one thing. If this is right angle triangle, then can I apply Pythagoras theorem? So suppose this is A, this is B, this is C, and this is D. Right? So what can I do? That BC square equal to this AB square plus AC square. So can I say 15 square plus 20 square? So can I say BC square equal to 225 plus 400? That is equal to BC square equal to 625. So what do I get? BC equal to 25. Is that clear? So this I am getting 25, this complete length. Now one more thing. What is the area of this complete triangle? If I take this as a base AB, then can I say my area is half into base 15 and height is 20? Yes, no? And if I take this as a base BC, then again the area is half into BC, means 25 into this height is AD, which I don't know. Can I say these two area would be equal because the triangle is same? Either we take base AB or we take BC, it doesn't matter. So half cancels with this half. So this AD equal to 15 multiplied by 20 whole divided by 25. So 5 4s are 5 5s are 5 3s are 3 4s are. AD is 12. I got the value of AD. Yes, no? So AD is my 12. And if AD is 12 and this one is 15 and this one is 12, by Pythagoras again I can find this BD value. Yes, no? So what do I get? This 15 square equal to the 12 square plus this BD square. Again I am applying Pythagoras theorem. So 225 equal to 144 plus BD square. So 225 minus 144, that is 81, right? Equal to BD square. So BD I got 9. Is that clear? So this 9 again obtained. And this is 25 complete. And this is 9. So can I say this one is 16? Okay. So So my target is to determine the length of this AB. Is that clear? Now I will try to find this radius of this small circle and the radius of the bigger circle. So please do remember one thing, the formula of in radius, the formula to calculate in radius in any triangle is A by S. So A means what? Area of triangle, and S means semi perimeter of the triangle. So please do remember this thing. Now if I say R for this triangle whose sides are this 15, 12 and 9, what is area of this triangle? Half into base is 9 and height is 12, divided by S means what? Semi perimeter. What is semi perimeter? Sum of these three divided by 2. So 15 plus 12, 27 plus 9, 36 by 2, that is 18. So this 2, 6 is 12, 6 3 is 18, 9 by 3. So what do I get? 3. So I got the radius 3 of this circle. Now again I want radius of this circle also. Again I am applying the same formula, R equal to A by S. So area of this triangle half into base 16, then height is 12 divided by, here the semi perimeter is 20 plus 12, 32 plus 16, 42, 48 by 2, 24. Is that clear? So 2, 6 are 12, 6 4 are 24, 16 by 4 is 4. So R is 4. Is that clear? So I got the radius 4. Now what people mistake usually in this question is that if they want to make AB length, then they take total of this radius and this radius, which is wrong, because these two circles do not touch at same point here. So there is slight gap you can observe in this diagram. Is this clear? So their point of contact is not same with this line. So you can't say that the sum of radius is equal to this height. So this length should be slightly more than the sum of the radius, because there is some gap here. So how to determine that radius is the main thing now here after calculating this much. Is that clear? So please, suppose I draw a perpendicular from here. If this one is 3, can I say this is 3? And if this one is 4, can I say this remaining portion is 1? Right? Now this is square. So can I say if this length is 3, then this length is 3? And this one, if this one is 4 complete, then this length is again 4. This one complete, because when, yes, this one is 4 up to point of contact. So again this one is 4. So can I say this complete length is 7, 3 plus 4, and this one is 1. So this hypotenuse is what? Under root of 7 square plus 1 square. So that is under root of 50. That is the correct answer. In exam, one option 7 was also given in that exam, and one option root 50 was also given. So by mistake the student take this 7. So that is wrong. So this is the correct answer, root 50. I hope that is clear. Okay, move on for the next very important question. Suppose this is the equilateral triangle of 6 meter length side, equilateral, all sides are equal, as I told already. This is suppose a circle, bigger circle, which touches all the 3 sides of this triangle, and there are 3 small circles at the corner, each corner, equal size, small circles of equal size. Is that clear? Now my question is this: what is the radius of this small circle? The original triangle is equilateral triangle, and these are 3 small circles whose radius is to be determined. Is that clear? Now height of equilateral triangle, as I already told you, root 3 by 2 into h. root 3 by 2 into a side is 6, so 2 3s are 6, so it is 3 root 3. Is that clear? So can I say the height of this equilateral triangle means this one is 3 root 3. Suppose this is center of this circle. Is that clear? And if this is center of the circle, then this would be centroid also. As I told you that in equilateral triangle, centroid, orthocenter, everything at one place only. So if it is centroid, then it will divide the whole length in the ratio 1:2. And if I divide this 3 root 3 into 1:2, then this would be root 3. And from here to here, this would be again, this would be 2 root 3. Are you agree with this? And in this 2 root 3, this is again root 3 because this is again radius. This is radius, so again this is radius. So the remaining portion upside this would be again root 3. Is that clear? I don't think there should be any problem in that. Now, if I draw a tangent here, then as tangent is perpendicular to radius, so again it would be 90 degree. And this already 90 degree. It means these two lines are parallel. Because this is 90 degree, this is 90 degree, co-interior angle sum is 180. It happens only when the lines are parallel. Is that clear? Now do one thing. See this triangle and this triangle. Can I say these two triangles are similar? This angle is 60 degree because this angle is 60 degree as equilateral triangle. Corresponding angles, again this angle is 60 degree because this angle is 60 degree, and this is common angle. It means this small triangle and this bigger triangle is similar triangle. Yes, no? Any problem? No. Now, this is center of this small circle, suppose. Again it would be centroid of this equilateral triangle. And if this height is root 3, then it would be 1/3 and it would be 2/3. So 1/3 of root 3, 1/3. So that is equal to root 3 by 3. So that is equal to 1 by root 3, which is my answer, which is the radius of this small circle. So this way we can calculate it. I hope that is fine. No problem. Okay. Now one last question I would like to take. Don't expect a very beautiful diagram with me, right? And beauty never important here in mathematics. Yes, what work we are doing, that is important. So this is the circle, suppose. This is the circle in this square, and there is one rectangle here of side 2 by 1. This is 2 and this is 1. Very small rectangle of size 2 by 1. Is that clear? And this is circle inside this square A, B, C, D. Suppose this square is A, B, C, D. Now my question is this: what is radius of this circle? This is the only question. Find the radius of this circle. Now what do I get? This is center, suppose. This I can join from here. This I can join from this side also. So can I say this one is radius of the circle and this is also radius of circle? If I join this point from this point, then again this is my radius of circle R. If I draw a perpendicular from here this way, right, I can draw one more perpendicular here. Now one thing, if this one is 1, then the opposite side, this is again 1, again this is also 1, and if this complete is R and this is 1, then what is that? This remaining is R minus 1. This complete is R. So the remaining is R minus 1. And if this one is R minus 1, which one? This one. Then this opposite side, this would be R minus 1. I think you are getting this thing. One more thing, if this one is 2, then this is again 2. And again this one is 2. And if this one is 2, then this remaining is R minus 2. Is that clear? And this is radius R. This is radius. Now we have this right angle triangle, in which if we apply Pythagoras theorem, then what do we get? R square equal to R minus 1 whole square plus R minus 2 whole square. Is that clear? So if we simplify this, we can get the value of r. So r square equal to, I can write here, so r square plus 1 minus 2r plus r square plus 4 minus 4r. So this r square cancels with this r square, then 4r and 2r, that is 6r. I can take this side, so 6r equal to 3. Just a minute, this is 4r and this is 2r, 6r I can take here, r square, oh sorry, one more r square is here, so it is quadratic equation we get. So that is r square then minus 6r plus 5 equal to 0. So if we simplify it, r square minus 5r minus r plus 5 equal to 0. So if I take r common, then it's r minus 5 minus 1, r minus 5 equal to 0. So if again I take r minus 5 common, what do I get? R minus 1 equal to 0. So r equal to 5 and r equal to 1. Is that clear? Now there are two values of r. Which one should I take? R cannot be 1, because if I take r1, then r minus 2, it would be negative. Length cannot be negative. And if this one is 2, then how this complete r can be 1? So 1 is entirely, this is rejected. So my answer is 5. So r equal to 5. So this is the radius of this circle. So please continue with this channel, subscribe the channel, and try to solve as many questions as possible. As the same question what you did, it's never come in examination, very less chances of coming that questions. So why we do these questions again and again? Because we are we practice more and more, so that we are able to solve the questions exactly of that type in the examinations. I hope you understood the session, you enjoyed the session. Thank you so much. Have a nice day.